Hi, welcome to this video. This is we're going to talk about topic number 1 of the fundamentals of actuarial mathematics course that will be starting real soon. So let me just go ahead and give you an overview of what are the things that we're going to talk about in topic 1, okay? So before that, right, let me tell you, it will be, I'll probably spend about 45 minutes of each, the first hour of every Saturday, talking about the ideas, and then the rest of the time we'll be doing problem solving. So let's talk about the first topic. Yeah? The first topic will be survival models. So under survival models, we will be talking about, well, let's start with TX. Let me tell you what we'll be talking about first, and I'll go into a little bit more detail. Yeah. So we'll talk about TX, and I'm sure all of you would have done some life contingencies in your life, so you know what TX is. And after we talk about TX and the related ideas, we will talk about mu x. What is mu x? We also know this is very familiar to us. Mu x is the force of mortality at hx. And after we talk about mu x, I'll tell you a little bit about mortality models. Okay? Mortality models. What are the models we're going to talk about? We're going to be talking about Gompertz, we're going to be talking about Maycomb, and I'll tell you a little bit about, what we call it, our de Moivre's law and generalized de Moivre's law in passing, right? Because we won't be using much of it. And then I'll also tell you about the constant force model. Okay? And after that, we will talk about actuarial notation. But when I say after that, it's not going to be entirely after that. That'll be a mix, right? So we'll talk about some actuarial notation. And once we're done with that, we'll talk about what do you think? Moments. Yep. We will talk about moments, like the expected value of Tx, the expected value of Kx, yeah, the variance of Tx, the variance of Kx, and stuff like that, right? And then I will finish off this chapter, or rather this topic, by maybe telling you a little bit more about what Kx is, right, in detail. That's basically the plan, right? So let me tell you again, right? Survival models is this baseline thing, right? So we're going to use this to deal with things like, life tables and insurance benefits and annuities and stuff like that. So I want to get this right from the get-go, yeah? So we'll start with Tx, then we'll go to mu x, then we'll go to mortality models. This is the easier thing, mortality models, because it's very formula dependent, right? Formula dependent. And then we have actuarial notation, which is connected to Tx, and then we'll come back and talk about stuff like this as we finish this topic. So again, let me tell you again, right? It's going to be about 45 minutes of going through the details, and then we'll spend the rest of the time problem solving. That's the quick way to learn this, yeah? Okay. Let's just have a little bit of fun, right? Okay, let's start with Tx. Let me tell you a little bit of Tx. What is Tx? Oh, I tell you what. Let's look at Tx and let's look at Kx. Now, why don't we put in some numbers, right? Let me just look at T42 and K42. Okay? Before anything, what is T? T is the complete future lifetime, yeah, of somebody aged X, but now it's age what? 42. What is T? T is the complete future lifetime. It's a random variable, of course. You don't know when that person is going to die. And it's the complete future lifetime of somebody aged X. I said X, but here I'm just saying X, let it be 42. Okay? Then, what is K42? This is the curtailed future lifetime. So the curtailed future lifetime will be what? Of somebody aged X. Here again, of course, I'm using 42 just to give us a feel of the numbers. What is curtailed future lifetime? The number of complete years lived by somebody aged X. What is this? The complete future lifetime of somebody aged X. They're different, right? This is the number of complete years lived by somebody aged X. In this case, let's look at age 42. Okay, let's say this guy, right? Let's draw a picture here. Okay, let's draw a picture here. Somebody age 42. So we have what? 43, we have 44, we have 45. Let's say, right, just for discussion, let's say the guy dies here. Okay? This guy who is age 42 dies here, let's say 44.6. At the age of 44.6, the guy dies. So again, 42, 43, 44, 45. Usually 42, this is the what age at issue. But never mind about that. We'll come to that later, yeah, when we talk about insurance benefits and all those other exciting stuff. So let's say the guy dies here. What is T42? So T42 is the complete future lifetime, yeah, of this person. What is this? 1 year, 2 years, 2.6. Easy, right? Okay, so this is a random variable, number one. Number two, it is a continuous random variable. Now, what about K42? The guy dies here. How many complete years has he lived? 1, 2. Easy? That's it. So, we are looking at one which is the complete future lifetime of somebody aged X, in this case is 42, and this is the curtailed future lifetime of somebody aged X, in this case is 42. So, I'm just saying, to get our ideas right from day one, right? This is the age that he's going to die. Let's just say we know it, right? He dies at age 44.6. So I have, this is 42, this is 43, 44, 1, 2, 2.6. And this one, the number of complete years is just, that's it. Okay? So now let's talk about some actuarial notation, right? Let's talk about some actuarial notation. Before that, right? Before that, let me tell you about mu, right? Look, we're just having a discussion on some of the broadly the things that we're going to talk in greater detail during my class. So, what is the force of mortality? Hey, look at this. Something that we live with, right? The force of mortality at age X, right? At age X. So, let me tell you what the force of mortality is. How do you learn it, right? How do you learn it? Learn it like this. Mu X. I'll give you the definitions during class, yeah? Okay? What is mu X dx? This is the probability. Okay, this is the probability, right? This is, look, this is for force of mortality. Let me write it down, right? Force of mortality at age X. At age X. Okay, one or two more ideas, right? In our introduction here. This is the probability, right, of dying in the next instant. Think about it, right? This is the probability of dying in the next instant. So you're walking, your age X, lightning strikes and you're dead. So this is the probability of dying in the next instant. Look, there's a dx here. I'll tell you about the significance of it later on when we talk about probabilities and so on. So besides this, mortality models, we'll talk about what? We'll talk about Gompertz. Okay, Gompertz is connected to what? BCX. And then we have got Maycomb. Will be A plus BCX. These are mortality models that we'll need to be pretty good at, right? We have mu x equals to Gompertz, right? Mu x equals to bc to the power of x. B is bigger than 0, c is bigger than 1. I'll tell you about that later, yeah? And then we have Maycomb, right? Mu x equals to what? A. Remember the constant, which is due to maybe some accidental death or something. So A plus B, c raised to the power of x. Good. Actuarial notation, we'll cover things like, watch, we'll cover things like TPX, okay? We'll cover things like TQX, the complement, and then we'll cover things like T/UQX, okay? This is the probability that somebody aged X will live up to X plus T at least. This is the probability that somebody aged X will die before X plus T, okay? And this is the probability that somebody aged X will live for T years, yeah? And die in the next few years, yeah? That means it's a deferred probability, right? So I have X plus T, and X plus T plus U. Okay, this is T/UQX. So he's going to live here and he's going to die here. Okay, so that's a deferred probability. So besides actuarial notation, we will talk about the expected value of Tx, which is E circle X. The expected value of Tx. We'll learn formulas like the second moments of Tx will be what? Will be 0 T TBX dt. Yeah, we have second moments. Once you have second moments, you have first moments. Square it, get the variance. Great. We can also do the same for Kx. Yeah, we have an expected value for Kx, which is what? Summation Kpx 1 to infinity. Expected value of Tx will be what? 0 to infinity Tpx.